Good morning, children. So today we are going to learn about the next part of the lesson, work and energy. So in the previous two videos, we have learned about the work. What are the conditions for work done? So when we call it as a work done, that we have studied. Then I told you about energy, definition of energy, what is energy, and types of energy. And we have derived the formula of kinetic energy, and we have derived the formula of potential energy also. So today in this class, we are going to study about the law of conservation of energy. Law of conservation of energy. So this law, see, in the second chapter we have learned, like chemistry, one of the chapters called as atoms and molecules. In that chapter we have studied about the law of conservation of mass. Same way, here it is energy. What it says? It says that energy never be created, not be destroyed, can be transferred from one form to another form. So this is the definition. This is the statement of the conservation of mass. As you know that sun is ultimate source of energy. From the sun, many of the energy are formed, like chemical energy produced during photosynthesis. So wind energy formed due to solar energy. So like this, we can transfer one form of energy to another form. Like we have said, see, sun is called the ultimate source of energy. So wind energy is a indirect form of solar energy. So solar energy only is converted into wind energy. Like this, we cannot create or not destroy. It can be transferred from one form to the another form. It is said that. That's good. So here, see, like total energy. The total energy which is present before the conversion and after the conversion is same. So it says that like whatever the energy during the transformation, some amount of energy will be there in the form of say mechanical energy. That mechanical energy is converted into electrical energy. When it is converted into electrical energy, the same amount of energy will be present. That will be always constant. Like I'll give an example. See, an object is here. Object A with certain mass. See, it is lifted. It is lifted to certain actually its potential energy was zero, was zero. When you lift this object at certain height, it gets a potential energy. Now the potential energy is somewhat you think that 20 joules, 20 joules, 20 joules of energy. When you raise this object to a certain height, it gains certain energy, that is 20 joules. So when it is raised, so it is in resting position. Raised and kept it is in resting position. So its kinetic energy will be what? The kinetic energy will be 0 joule. 0 joule. Try to understand my point here. So after the conservation of means during the conservation of mass, say like when one form of energy is converting into another form, before and after the energy will be same. The energy will be constant. That we are proving over here. So as you know that object was in the floor, and we are lifting it to certain height, and it gets the kinetic energy of 20 joules. You think that, right? So when it is lifted, it will have kinetic energy. Kinetic energy will be 0 joules. Zero it is. Why it is 0? See, kinetic energy we know that whenever there is a object is in motion, it gets a kinetic energy. Now the object is in rest, that's why it gets a kinetic energy because they have raised to certain height. That's why the kinetic energy is 0, because kinetic energy, object will get a kinetic energy when it starts moving. Here it is a certain height, like you think that here the object is raised to 4 meters. Now you have reduced the height to 3 meters. You think that the joule, so this object is made to fall. So this object is made to fall now. When it reaches the 3 meter height from the ground, it will increase. It will decrease its potential energy. Here the kinetic the potential energy is converted into kinetic energy because it is in motion now. Now what about the kinetic energy? So kinetic energy will be how much? Like 5 joules. Because here it started moving now, that's why it's 5 joules. So what is the difference now? 15 joules. So potential energy plus kinetic energy. Kinetic energy is equal to 20 joules. See, it is constant. Before and after it is constant. See, 15 joules. By reducing the height, it gets a potential energy of 15 joules, and it raises the kinetic energy. Kinetic energy was 0 here. It was raised to 5 joules. So when you add sum of these two is called as mechanical energy. See, it is constant. Potential energy and kinetic energy, after the transformation, it is constant here. Then you think that again it is reduced to 2 meters. So here it is reduced by 10 joules. You remember, like 10 joules. So kinetic energy will be reduced by 10 joules. Will be increased by 10 joules. Now PE plus KE is equal to 20 joules. 10 plus 10, 20 joules. Here 15 joules plus 5 joules is equal to 20 joules. Here 10 plus 10 joules is to 20 joules. Then again it is raised to 1 meter. 1 meter is inside. What happens? Again, so 5 joules, then potential energy, kinetic energy becomes 15 joules. So here potential energy plus kinetic energy equals to 5 joules plus 15 joules is equal to 20 joules. See, it is again constant. Now finally it has reached the floor here. So now it has reached the floor here. What happens here? The kinetic energy, now the potential energy, which was 20 joules, it becomes 0 joules because it has reached the floor now. So Now the kinetic energy before reaching the ground, kinetic energy before reaching the ground is 20 joules, 20 joules, 20 joules. Like this way, if you see, the after the transformation of one energy to form to another energy form, the energy is always, it is after and before transformation is constant. So that we have proved it. So during the transformation of energy, the energy remains constant. After the transformation and before the transformation, it remains constant. So this is there in the textbook. It is there. It is given in the textbook. Go through that. So we'll see the we'll see the next concept of the lesson. That is far concept. Far concept. Far concept. So power means what? So power is a rate of doing work. It's called power. Rate of doing work. Say like, see, energy. They are doing some. See, all the people are not same. Like some will have the capacity to do work is more in some people. In some people it is less. Say like if you give example like the bulb. See bulb will be like 6-watt bulb will be there, 12-watt bulb will be there. What is this watt? So this watt tells about the power of doing work. Power of doing work. So 6-watt bulb means what? 6 watt of power is exhibited, right? Bulb is used in the electric circuit. What it gives? It gives a light. So amount of heat energy liberated. Amount of heat energy liberated by this through bulb, that is called as power. Amount of energy. Say bulb usually works on electricity. How much electricity is used by this through bulb? It's called as power. It's called as power. Like, see, rate of doing work. So what is the SI unit? So SI unit of power is joule per second. Joule per second means, so for 1 second how much work is done? Work is done. Like 1 second how much joule of work is done, or 1 joule for 1 second how much joule of energy is converted by a device or something like. See, SI unit. See, if I tell the power is equal to 50 watt. 50 watt. So what do you mean by power is equal to 50 watt? Before knowing this, we'll see what is the equation for power. So power is equal to work divided by time. That is P is equal to W divided by T. This is the equation for power. That's it. Equation for power. So as you know that already, P is equal to W by T, work done and time taken. So you know the work done. So work, the unit of work is joule. And time is second. That's why the SI unit of power is joule per second. See, joule per second is also stated as watt. So you the scientists call as James Watt. James Watt. So this power concept has been derived from the James Watt. That's why in his name, SI unit of power, that is joule per second, is called as watt. So what do you mean by 50 watt? 50 watt means what? Means 50 watt means what? 50 joule of energy is consumed in 1 second. 1 second. 1 second. That's the meaning of 50 watt. So what do you mean by 1 watt? 1 watt means what? 1 watt means what? If 1 joule of energy is produced or consumed in 1 second is called 1 watt. 1 watt. So if 1 joule of work is done in 1 second, that is called as 1 watt. 1 watt. Understood? So higher unit of, what is the higher unit of watt? Higher unit of watt. Higher unit of watt is 1 kilowatt. 1 kilowatt. 1 kilowatt is nothing but 1000 watt. What do you mean by 1000 watt? 1000 watt means 1000 joule per second. 1000 joule per second. So this is about the power concept. So every devices which we use in electric circuit or in a domestic circuit will have certain watt, which is the amount of energy produced by that device. That is called as watt. I hope you understood this concept of watt. So this is about the last concept of the lesson, work and energy. Work and energy. Some of the numericals is given in the given about this. Please go through that numericals, and I will give. Already I have sent some of the numericals on kinetic energy and potential energy, and combination of both. So that you have to solve it. I don't know how many of you solved those questions. So some of you already asked some doubts in that, and some of you sent the solved problems. So I request all the children to solve that problems and send the answer. And I request you to solve the exercise questions and in-text questions also, which are based on the work, potential energy, kinetic energy, all the problems. Like power also it is added. Just go through that. So, say commercial unit of energy. Commercial unit of energy. The commercial unit is always calculated in kilowatt hour. That's true. Kilowatt hour. So what is 1 kilowatt? 1 kilowatt is equal to 1 minute. 1 unit. This is the unit, commercial unit of the energy. Commercial unit of energy. See, using that sense. See, if I write 50 watt, it means that 50 joules joule per second. So in 1 second, 50 joules of energy is consumed. Similarly, see 50 joules. See in 1 minute, how much joules of energy is consumed in 1 minute? You know that 1 minute is equal to 60 seconds. So 50 into 60. How much it comes? Comes around 300 joules per second. 300 joules per second. Means in 1 minute, 300 joules per second. Per second of energy is consumed. Like here, 50 joules per second. In one second, 50 joules of energy is consumed. In 1 minute, how many joules of energy is consumed? So in 1 minute, 300 joules per second energy is consumed per second. Similarly, if you take 1 hour, 1 hour is how much? 50 into 60 into 50. So 50 into, I'll write it over here. So 1 hour, 50 into 60 into 60. You know that 1 hour is equal to 50 minutes and 1 minute is equal to 60 seconds. If you multiply this 50 into 3600, how much you will get? So say 1,80,000, 1,80,000, 1,80,000 joule per second energy consumed. Like this way, if we calculate, it becomes for 1 hour it is this much, means in for 10 hours. 10 hours how much it will be? It will be more numbers. So biggest value will come. So see, it is not easy to a person who is calculating the energy consumed by the devices which are used in the electric circuit. You know electric circuit. So electric circuit we use in our house. Generally we use electric circuit for everything, like for lighting purpose, for heating purpose. We use domestic circuit. In that circuit, some devices are used. They will be giving devices. How much energy that devices use in 1 minute, 1 second, or 1 hour. So similarly, 10 hours, how much it will consume? How much energy is consumed? If you 10 hours, if you take, it will become a huge number. Then in 30 days, how much amount of energy consumed by that device? So 50 by divide in one month, that is 30 days, how much of energy is consumed? That becomes a too much number, like a toll-free number. So you have biggest number will come. It is very difficult to calculate. That's why energy, commercial unit of energy is calculated in kilowatt hour. One kilowatt hour is equal to what? 1 unit. So on 1 unit, how much energy is consumed? 1 unit, how much energy is consumed? As you know that 1 kilowatt. 1 kilo means 1000 watt. 1000 watt into hour. 1 hour is equal to how many seconds? So 3600 seconds. 1600 seconds. Here, how much it will come? The value 1, 2, 4. 6, 0, 0, 0, 6. So 3, 0, 0, 0, 0, 30. So 0, 0, 0, 0. Here, how much? 36 lakh energy will be consumed. See, means for 1 kilowatt hour, how much energy is consumed? That is 36 into 10 raised to 5 joules of energy is consumed in 1 unit. That is 1 kilowatt. 1 kilowatt. This much of energy, joules of energy consumed in 1 kilowatt. In some of the textbook they may given as like 3.6 into 10 raised to 6 joules. It is also right. So then we have put a point over here. We have written 1 more over 10 raised to 6 joules. Understood? So 1 kilowatt hour is equal to 1 unit. On that basis, they actually generate the bill of the electricity or kV board. They generate the bill on this basis. So this is the commercial unit of the energy. So here some of the problems are given in your exercise and in text. Please solve it. If you have any doubt, you can ask in the next class. So next class we will do some problems on power also, and we will do some problems on kinetic energy and potential energy also. So with this, we'll stop the class for today. So once again, I am reminding you to calculate, solve the numerical on power, kinetic energy, and also the potential energy and work. So with this, so work and energy chapter is completed. So if you have any doubts, please let me know in know through WhatsApp. So some of the problems I gave you already yesterday, I have sent you. Please go through that and solve it. If you have any doubts regarding that, please call me. Thank you very much, children.